Now I'm going to machine all the flat area now. Let's create a new cutter for this flat area. I'm going to highlight this and click on new tools. Then you will create another one with the same parameters. But this one I'm going to change the name to flat ML finish ML8. Use a flat one, and then yeah, that's it. This is a cutter that we're going to use for the flat area cut. And after that, I'm going to copy this process into another one. Change this to flat finish. And I'm going to edit this process. Now the function is the surface milling and the finish horizontal planar area. These functions. And I'm going to reset the check surface that we select by the previous process. So I'm going to reset all and go back to part 3. I'm going to select it by criteria. In this case, I will select the flat face, and now I've selected all of the face. And next, I'm going to go to go to cutter tab to select the flat mill, the cutter, and then of course this is finishing. So I'm going to change all the offset to be 0. And the surface tolerance, the finishing tolerance I will suggest for a normal part. It will be from 0.007 to 0.003. So in this case, from 0.005 is, I think it's okay. And this is the approach tolerance, the tolerance of the approach. Then over here you can choose whether you want to select a spiral cut to cut a flat area or parallel cut to cut the flat area. In that case, I will select a parallel cut. And machining orders, it will connect by the closest. If there's jump, you jump to the closest point. And horizontal cutting, if I choose climbing milling, then the parallel cut it will cut at one direction. So a lot of jumping. In this case, I will use a mixed mode so that the cutter will not jump. And how about the side step? Maybe I will choose 70% of the cutter diameter. That's around 5.6. Mill angle, do you see an arrow here? Okay. The arrow indicate the milling directions. So in this case 0. I think I'm going to mill at 90 degrees. Okay, and you can see the arrow is changing. Okay, and the big arrow is the start directions. If you don't like to start from the left side, then you can flip it. You can flip here. Then it will start from the right side. And let's execute. Now let's look at the result. All the flat area is automatic recognized and machined by this flat ML8. And okay, so because of big side step of the parallel cut at the side of the surface, at the boundary of surface, you might have some scallop remain. To prevent this, you can on this. There's one option here. You can on these parameters. The parameter is final pass. You just turn it all around to on it. And margin for the final pass, the gap Okay, for the final part, you can choose optimize, or you can put in your own figure, the margin. So I want to use optimize, and let's calculate. Okay, let's navigate again. As you can see now, after the parallel cut, the cutter will move add an extra pass at the boundary of the region, the flat region, and cut a final pass. So this is the extra pass. So this passes, it will cut away all the remaining scallop. So I'll suggest on the final pass if you use a parallel cut. Okay, make sure you're on the final pass. And one more thing, I think you also notice over here you can see the two paths, right? It's going around something, okay? This problem is because of this flat face here. We might have this flat face is not trimmed properly, and you have a small amount of surface higher than the green surface. That's why you have this pass to go around this edge. If you really want to solve this, you need to retrim this face with this face to remove the extra edge. Or I think it should be okay for this part. Okay, that's it. Flat area cut. Before we touch on the pencils, I'm going to explain how the pencil process detect the corners. So in penciling process, Cimatron is using the cutter radius touching point here. Okay, cutter radius, the tangent touching point. So if you have bonus and this radius of bonus smaller than the corners, then you have a two touching point. And from this, Cimatron can know where is the corner to machine. And because of this one, the bonus cutter is okay for pencil. Bonus is okay for pencil. For flat cutters, no. For flat cutter, no, because flat cutter don't have any radius. Next, I'm going to show you how to create some penciling process. So, before finishing, it's good to apply a finishing process. So, I'm going to copy this process. Okay, I will say pencil. And I will change this surface milling to a remachining functions called pencil. Okay, so the surface and also select all except the flat surface as a check surface. And The offset. In penciling, if you don't have 90-degree wall, and you can always reduce the offset, maybe reduce to 0.1, and this one also maybe, yeah, 0.1, and check surface is okay. In this case, my check surface I also put 0.1. So the surface tolerance let's put 0.05. In penciling, if you reduce the surface offset to become smaller, and if you use a strict shank tool, and you on your part, some area that you might have some area that is 90-degree wall, you have the risk of the shank touching the wall. Okay, so if you can choose a lollipop type of tool, there will be a best tool for the penciling. So the best tool for penciling is something like a tool, something like this, the lolly type of tool. Okay, I mean the shank is smaller than the cutter diameter. If you use this kind of tool, you can machine a 90-degree wall without the shank touching the wall. Okay, tool trajectory. Again, you can have the option to choose what type of cut you want to use. I'm going to use kind beam milling. The slope angles, okay, they put 40, it means that 0 to 40 is horizontal, 40 to 90 is vertical. And again, you can control the vertical. This is for the horizontal area, climb cut. This is vertical. For the vertical area, you can control whether to cut up and down, or up only, or down only. Okay, so in this case, I will use up and down. And let's calculate. Okay, so this is the penciling process. You can see the tool just go cut all the corners that is smaller than the cutters. Go one time, machine all the corners. So this will help to remove the excess material at the corner, so that the life of the finishing tool can be longer. This is penciling. Again, if you're afraid, only one pass is not enough. Maybe you may suspect there's a lot of material remain. You can always change these parameters here. Multi-pass. You can on this to set it. Okay. In multi-pass, you have two options. One is incremental jack. That means you copy the passes by jack directions. The other is by surface offset. I would suggest to use the surface option is better. Then you can key in how many pass you want. Maybe I will say I want to key in 3 pass, and then the step size of 1 pass. So if I say I want it to be 0.3, so then it will automatically copy 0.3 and copy the pass 3 times. There you are. You can see now, instead of one pass, now you have 3 pass. Okay, 3 pass. with 0.3 mm pitching downset. So in penciling, sometimes you can use it to clean up the corners, especially for big mold. For a very big mold, sometimes your last roughing tool or the semi-finishing tool may be diameter 16 or diameter 20. Okay, let's say your last roughing tool or last semi-finishing tool is diameter 20. Then you can use a diameter 16 tool to do a penciling. After that, you can use a diameter 12 to do another penciling to clean up the corners, and then you can use maybe a next diameter 10 tool to clean up corner, and after that you can use a diameter 8, something like that, to clean up the corners. So penciling is very useful uh, to clean up corners, especially for very big mold. Now let's check the curvature of the model again. You can see that I think the minimum cutters over here is 2.5. So the cutter that we're going to use, the last cutter maybe is down to diameter 4. Okay. So again, now after penciling diameter 8, so next I'm going to use diameter 4 to rough out all the corner by using the cleanup functions. So first we need to create a new cutter for this. So create new cutters, rough EN4 and diameter 4, and the cut length 10, this will be 15, and of course normally for this diameter 4 the shank is 6, so bottom is 4, the top is 6, cone height maybe change to 10, let's change to 20. So this will be the cutter that we're going to use for the roughing at the corners left by the bonus diameter 8. Let's copy this process. So the function that we're going to use again is remachining and cleanup functions, and in this case again the geometry, I'm not going to select any check surface, reset all. I'll select all the surface to cut, including the flat face, and next go to the tool trajectory and motion parameters. Let's look at the tolerance of the offset. In this case, in cleanup, if you use cleanup for roughing purpose, we don't set this offset here. Over here we put 0. Of course, this we put as surface tolerance, and finishing tolerance this one, and we put the offset here to trajectory and offset reround. Okay, so over here you put, let's say I put 0.2. It means that Cimatron will check and offset the model by 0.2. Okay, for the roughing. And in simple words, Cimatron will check the model. If you have some material that is more than 0.2, then you cut the material, the area that is more than 0.2. This is vertical step of the roughing. I will put 0.5, and this is the size that I will rough. 40% of cutter is okay. And of course, make sure you select this bonus 4 as your current cutter. And climbing milling. Yeah. So over here, machining regions, I will change it to none, so that I only generate the roughing process, not including the finishing motions. Okay. And next parameter is the previous cutter. CimatronE will use the previous cutter to detect all the corners. This also means that the cutter that you can use, same as pencil, you can use only radius cutter, not a flat angle cutter. And previous cutter offset, if I put 0.5, it means that it will use a diameter 9, diameter 8 plus 0.5 per side, that is equal to diameter 9 cutter to detect all the corners for the roughing. And execute. One more thing regarding this offset rerough that I mentioned here. So if your model you have some 90-degree wall, and this offset amount you put less than your semi-finishing offset or roughing offset, and if you are using a straight shank tool, then the shank may touch the wall. Okay, the shank may touch the wall. If you keen this offset rerough larger than your semi-finishing offset or the roughing offset, then no such issue will happens. And of course, if you don't have 90-degree wall, in this case, my model here, I don't think we have a 90-degree wall. I think it is okay for me to put 0.2. And this is the result. There you are. You can see you only cut those areas with 0.2. So after cutting, you still have 0.2 offset at the model. And you can see this cutter can only cut until here. This is because of the shank limitations. The shank limitations. Okay, if the cutter go and machine this area at the bottom, and it might be an issue. The holder or the shank may hit the model. Okay. So CimatronE will automatically avoid those areas that the cutter cannot cut. This is the roughing process by using the cleanup function. Now I'm going to cut do some finishing on the cavity face and the internal parting surface. I'm going to go to CAD, create some sets, okay, so that it can ease our selections, make it easier to select the geometry. So I'm going to change color to use this. Okay, so I'm going to create a new set for this called internal part. surface. I'm going to choose by criteria this color over here. So now I have one here, and then I'm going to create another one external. Face. Again, I'm going to by criteria. This time I'm going to use this to get this color and set my criteria to color, this color. So now I have two, one external, one internal parting surface. And after that, I need to edit my this set to parting face set. Let's cancel this. I'm going to change those sets, internal and external. Okay. Let's save the file. Next, I'm going to create a new finishing bonus 8 FDNA, same parameters, and then I'll copy this process. And let's edit this process. Again, finishing, I'm going to use surface milling and by linear angle. This is the most popular finishing function in Cimatron that mostly a user will use. And okay, in this case here, okay, I don't want to cut the black face reset. I also don't want to cut the all the parting surface reset. So for the parting surface, I will select only the internal face, internal parting surface. And here I missed out something. This face I'm going to change it into internal parting surface also. So later on I'm going to change it. And next here, part 3, no part 3. So I'm going to select others as my check surface. Again, I'm going to select, for example, the external parting surface and the flat face as my check surface. And this is a surface that I don't want to cut. And as you can see, this face now is selected as the check surface because this is part of the external parting surface. So I'm going to change it. So I'm going to save and close, and then go back here, get this color, the same color, again get this color, and I'll change this face to the same color, right? So I click this process again, you can see now this face is recognized as the internal parting surface, right? So as you can see, if you use a set to control the selection, it's easy to manage. Next, I'll go to the, of course, select the finishing cutter, finish bonus 8, and then next is motion parameters. And the first thing that we look at, of course, is this area here. So since this is a finishing, the offset all is 0 except the check surface. In this case, the check surface, I think I will put 0. Okay, and check surface of the 0, then the rest, this is okay. And next, go to true trajectory, and this is finishing. So horizontal area cut, I have the option to choose spiral, parallel, or 3D step. So I'm going to choose 3D step to get a constant pitching on the horizontal area. And cutting directions, inside or outside out, inside in, inside out or outside in. So I'm going to choose outside in for finishing. And the step I'll put maybe 0.3. And I'm going to use a true spiral options. And next, the vertical area, I'm going to on this. I'm going to cut a vertical area also. And for the vertical area, we have different options. We have a layer cutting, helical cutting, and bumping. So layer cutting is good to maintain the accuracy of your vertical area. Okay, layer, because only two axes is moving, x and y. So if your machine accuracy is an issue, please use the layer. Okay, it will give you more tight accuracy control on the machines. So I'm going to choose layers, and the vertical step I will put same as this horizontal step, CLSS. And you can also select the variable vertical step. If you choose this, what you need to do is to key in the required scallop that you need and the maximum down step. And Cimatron will automatically adjust the vertical area for you, the down step. So in this case, I'm going to use this fixed vertical step and hit horizontal plane. If I'm going to check it, what happened? This is what happens. Okay, it will automatically create another pencil motions touching the horizontal face. And machining orders, you have the option here to decide you want to machine all the vertical area first, or all the horizontal area first, or mix, optimize. Okay, so if you want to control a very tight accuracy at the vertical area, I would suggest to machine all the vertical area first, because if this vertical area machine first, that means the amount of wear will be minimum on the vertical area. In this case, I'm going to choose optimize. Optimize is let the systems decide. Yeah. Slope limit angle. This is the angle that controls a horizontal and vertical area. If 40 degree, that means 0 to 40 is horizontal area, and 40 to 90 is vertical area. And let's calculate. Yep, if you put your check surface offset to be 0, you have this message to give you a suggestion. So your check surface supposed to be 2 times your tolerance. Okay, and we put it 0. Okay, so this is the suggested setting for the check surface offset. So if you know what you are doing, you can click yes. And here you are all the finishing cut for the cavity face and the internal parting surface. Okay. And you can see here you have some hole here. This area is not machined. Why? Because the cutter cannot machine. It's because the cutter is not long enough. Okay. And that is our limitation of the cutter. Now, sharp edge control. Let's look at this process. We can see now this edge here is sharp. This parting surface edge is very sharp. Okay, and if our two paths moving round like this, okay, this edge it will not be sharp. You might have some radius over there. So how to overcome these problems? Okay, is to select this edge as the sharp edge and control the sharp edge. How to do that? So again, for the ease of selection, normally I would like to create sets for this sharp edges. So I'm going to create a composite curve over here on the surface boundary. Let's change to maybe yellow, and I'll change the thickness of line to maybe 5. So this is a sharp edge that we want CimatronE to control. So I'm going to create a new set, sharp edge, sharp edge, and choose criteria, and this is yellow color, and also the entity. I want only composite curve for these sets. Okay, now I have a sharp edge. Next, to have sharp edge control, I need to edit this process over here. Now we don't have it. You see, this area is round. So first I need to select the sharp edge. Here, click on sharp edge, and I'm going to use a criteria to select the sharp edge. Sharp edge. Okay. Now go to the motion parameters. If you should select sharp edge, you should have these parameters. And short connection over sharp edges. You have 3 options: round or sharp. So let's see. Here's some pictures. This is none. You create a tangent in, tangent out connection. Sharp is just a sharp motions, and round you create some round over here at the corners to maintain the sharp edges. So I'm going to choose in this case round. Okay, and that's it. Yes. Now let's look at this motion again. You can see after we control the sharp edge, there's no motions, no round motion go over the sharp edge, and this will maintain the sharp edge to be very sharp. Here I will demonstrate how to control the sharp edges. Okay. I have a finishing process here, And this process, I'm using surface milling by milling angle to cut the horizontal and vertical area. And in this case, I didn't select any sharp edges. Okay, so this is what happened. The motion of the cutter will make the part round. After you cut this with these two parts, these sharp edges, it will be not sharp, it will be round. Say for this vertical, the red color is the vertical edges. Right, the horizontal edges also is if you machine like this, if you machine like this, okay, horizontal edge also will become round. Okay, the round is not big, it's maybe a few microns or 10 microns maybe. Okay, so what happens if you want to control it, make it sharp? Okay, now look at the second one. Second one, I've selected the sharp edges, all the sharp edges, and then under this option here, we have the short connection over sharp edges. We have three options. First, I'm using none. Okay, so this is the result of the none. This is what happened. The cutter will move out tangentially outside and come back again to the edge tangentially. So this will maintain the vertical edge to be sharp. Same also for the vertical area, you only start cutting at the touch point of this edge. Okay, and horizontal also you start cutting also at this edge here. So this will also maintain the sharpness of the horizontal edge, the yellow one. Okay, how about the other option, the sharp? Okay, if I change the sharp, you can see this area, instead of tangent in, tangent out, it becomes a sharp motions. Okay, it becomes a sharp motions. And this also will help to maintain the sharpness of the vertical edge. How about the round? Round, CimatronE will create a small round, okay, at the corner. Okay, this one also will maintain the sharpness of the vertical edge. Okay, now let's look at the long connection over the horizontal edge. Okay, so if I put none, the result is something like this. This is the parameters. On the short connections, I'm choosing now a round, and long connection over the edges, I'm setting none. Okay, I don't check it. So this is a result. What happens if I check this? If I check this and set it to the minimum, that is 10 micron, this will be the result. This one I check it and set it to be 10 micron, this parameter. This is the result. So if you check the long connection, you have this waterfall motions. This is called waterfall motions. Shift upwards by 10 micron if I key in 10. That means the cutter is not exactly touching the edge, but is on top of that edge, 10 micron. Okay, So what happen if I put 10? Let's make it clear. Now I change the long connection shift to 10. Okay, this is the result. You can see the water 4 motions being moved up by 10 mm. Of course, normally we don't move by this much. And most of the time we only move maybe a few micron again, 0.1 maybe maximum, to avoid the cutter touching the horizontal edge. By default, the non you can use it. This is good enough. Okay. Now I'm going to focus on the external parting surface. Create another process here. Finish external face. I'm going to use the same tool, and in this case I'm going to reset all, reset everything, reset the cavity face and also the internal parting surface. So I'll change it to maybe the part surface that I want to cut now. It will be the parting surface, the external parting surface. So I'm going to choose the external parting surface. Okay. And the check surface, it will be the all other surface. That will be the cavity surface, internal parting surface, and also the flat face. All other surface as check surface. And okay, and this next here at the check surface offset, I'm going to put some offset, maybe 2 times, 2 times STOL, 2 times tolerance, so that when cutting it will not touch the cavity face. And other parameters I will keep the same and execute. And as you can see, we have some problems over here. This area at the side, the tuba is dropping into at the bottom, drop to the bottom. This one also. Why? This is because at this side we don't select. We never select any check surface or a boundary to control this edge here. So now I'm going to create a boundary to control it. Again, I will go to the CAD mode, create a composite curve, maybe change. I'll create this boundary to tell Cimatron that this is the boundary that this is the boundary that I'm going to use it for the machining. Okay. For ease of selections, again I will create a set for that. Boundary curve. Again I will use criteria, this color, and also the entire type. It will be the composite curve. There you are, the boundary. Next, I'm going to edit the process and select the boundary options here and right click these criteria. I'm going to select the boundary sets. And if you forgot to set the cutter location reference, okay, you can click over here again and it will list back the cutter location reference for this contour, and here you can change to a touch point. Okay. I will change the S touch point. What is on, in, out, and touch point? On means the cutter reference always from the top is always at the center. In is that means this cutter reference is always tangent inside the contour. Out is always tangent outside the contour. Okay, from the top. How about touching? Touching, it means that you cut until the two touch the boundary. Okay, the cutter touch the boundary. This is touch. Okay, that's why in 3D, the best option is to select touch. Yeah. Now I'm going to click OK. Select this as the boundary, and then let's calculate. So now you can see with the boundary control, the cutter only cut until touching the contour. It will not drop down. Cut until touch the contour. Okay, so there is no dropping down. Okay, next I'm going to work on the corners. Previously we already create a roughing of the corners. We rough all the corners in case with the ball nose fall. Okay, all the extra material. So now I'm going to do some finishing on the corner. So I go copy this, put here, and I'm going to create a new cutter, ball nose fall, new cutters, FBN4. Select this, and I'm going to change it to ball nose fall, FBN4. Of course, offset or 0. This finishing. And since we have done the rerough, now I don't want the rerough. I only want the machines, the corner, the finishing. So I cancel this. You must select this option in order to cancel the rerough. Yeah. Machining regions, you can choose to machine horizontal and vertical together, or all along means that you machine all the corner along the corner directions. Yeah. Or you horizontally, that means you cut only the horizontal corner. Vertical is only vertical corners. Okay. So how to separate horizontal and vertical is separate by this slope angle. If I put 45, 0 to 45 is horizontal, and 45 90 is vertical corner. This is a pitching of the horizontal steps. I will put 0.3 now for this exercise, and this is a pitching and vertical step. Also, I will put same. I will put CLSS. use the same variables. And previous cutter offset, of course, this one is the finished spin cutters, FBN8. Okay, if you don't change it, it's still okay because it's same. The diameter is the same. Previous cutter offset 0.5 is okay. So what is dilute pass? We look at F1, press F1 and look at these pictures. Dilute pass off is like this. Okay, when you on it, it will be like this. Okay, look at the back. So it depends on you want on or off. So I'll on it for now, and then calculate. Okay, maybe we'll look at these locations. Navigator. Okay. So if you have a horizontal corner, you cut along the corner. Okay. If you have a vertical corner like this, you cut across the corner. So for the vertical, if you don't like to cut across the corner, then you can always change the options, this option to all along the corner. Yeah. Next, after complete the programming, of course, the next step, the last step is to post processing, to convert this kind of machining lines into G codes. Okay. So to post, if you want to post everything, that means you can straight away select the whole TP, and then just go to post process and choose your post processor. Different machine might have different format. Due to that, you might have different post processor. Okay, for now we just use a demo. This is the area that you put put your programs. I'm going to put inside D training here. Okay, so you can rename the files if you want. Show output, rename. Let's say I want to rename all files. Maybe I'll say all.nc and post. So what happens? You post everything, all the cutters. It will be inside a single G code. And here's a G code. Again, if your format, machine format is not same, I think most of the time it's not same. Please contact us. We'll modify the post according to your own format. Each post here you have some G-code parameters. For example, over here, different posts might have different parameters. Right, this is the programmer all numbers of the programs. For example, and sequencing, yes, no, do you want a sequencing or not? Sequence start number, incremental number, subroutine. Okay, do you want all the subprogram control or not? Everything can change here. So if you don't want it, just press N. Let's say most of the time for 3D milling we don't use subprogram. You can always choose N. Okay, so this will control how the NC is output. Again, what happens if you don't want to output all into one NC file? For example, you might want to output just, for example, this cutter. Okay, one cutter, one NC file. What you need is just to select one process and then go to post and and it will give you one file. Okay, this is just only one cutter. So it depends how many process you select. If you select one process, then it will be one NC file. If you select maybe 2 or 3 process together and go post, and these 3 process will be inside one NC file. Okay, so this is regarding the post processing. Next, how about the NC setup report? Okay, so you can go NC process, and under the here you have NC report, and here you can actually capture some pictures, some photo for the NC report, and also you can select which style that you want. You can have Excel or PDF or NHD. NHD, this file you can open with Internet Explorer, and again you can use Excel Word to edit this file if you want. Template names, I'll choose the standard demo. Then this is the location of your setup sheet, so I'll put somewhere at the D drive, and training, yeah, this folder. You key in your something here, and then just click OK. Let's choose everything, the whole TP, and generate the setup report. This is the setup report. If the format is not suitable for you, we can teach you later on how to modify the format of the setup sheet. Next, I'm going to show you how to machine another part that is almost same as this one, except mirrored. So the first thing that I'm going to do is to save the whole TP, all the process that we have done for this part, into a template. Just select the whole TP and save as template. This is a machining template. And if you selected single TP, the extension is .tbt. If you have selected a few TP, 2 or 3, and then the extension will become MTT. So I'm going to save as this name and click OK for the machining template. Sometimes if you need to save a template for individual process, you can do that. For example, here, just select this process, right click, and save as template. Okay, but for process template, the extension is PCT. Okay. Beside the machining template, next we need to look at the sets, because we link our NC process, the selection, to this standard set. So you might need to save a copy of the standard set and use it for later. So how to do that? You just go here, File, and go Save as Template. Okay, so I'm going to put use the standard name and save the template for the sets. After that, let's close this file. And we're going to import another IGS, the mirror IGS file. And this will be the part that we're going to machine next. I'll create a new document, go to NC. When I create a new document, I can straight away create from the standard template or the template that you have saved. So in that case, I would start from the standard template and see. Then I'll save this. Same as names, I will save as same as this one. see. And then I'll load the mirror part into this NC document. And now I'll go to the CAD mode. Let's hide this UCS. I'm going to create a new one for this part. It'll be somewhere over here, and move it up by 1 mm. And then I'll rename this as G54, for example. Right, and activate this UCS. Okay. So next I need to assign the face into the standard set. So how to get a standard set? If you don't have it, you go to import for template. From template, again go to choose your template, choose this template that you have saved just now, and there you are, the sets here. So next I will do some coloring process. Okay, so you might have your own color code for machining. So I would change this to this color, this face also to this color, and maybe this face to this color. Right, so now I check. For example, cavity face, this is okay. And how about the internal parting surface? This is also okay. And how about the external parting surface? This is good. And parting face, okay. And this face is the non-machine face. I'll change to maybe this color here. Let's check. Right, non-cut face. And about the flat face, you can see the flat face, maybe the color of the flat face. Okay, now I have selected a different color and the set is not picking up the face. To solve this is easy. You can always use this pick this color to the current color and edit this flat face and cancel the existing and choose the current color again, so to edit the set. Okay, so now we have all the sets ready. And one more thing that is lacked is this composite curve. I might need to create a composite curve over here to control the sharp edge. Okay, this is the sharp edge. Yeah, it's working. Another composite curve for the boundary. Change it to blue. And let's check the boundary. Is it properly pick up the sets? Yes. Then that's it, finish. Next is switch back to CAD mode, apply a template, I will choose back this same template that we said just now. And again, you can see here, if the process, you have a symbol here C, that means the process is the selection of the surface is linked to criteria. Okay, you are using criteria to select the surface linked to the sets. This for the part node, so that's why you need to edit the path and part to select the surface and execute again. Same also for the boundary box. So I might need to go to put a bound box, okay, and then go back to the box and put this one to 0 to create our stock, and okay. So for the rest, since the selection is linked to the our standard stats, we no need to edit the selection anymore. What you need is just select the whole TP and select execute, and then select OK.